Hi all, welcome back to software engineering course. Let's get started. Next we will see about the requirement specification. So as we had seen in the requirement process diagram, the final output is the SRS document. We had two phases there, analysis and description. So the analysis phase precedes the specification. Now the first question arises here is, if formal modeling is done during analysis, why are the outputs of modeling is not treated as an SRS? Here in analysis, formal modeling is done. That is nothing but problem structure analysis is done. Now once that is done in analysis, why the analysis output is not considered as a SRS? The main reason here is that modeling it generally focuses on the problem structure and not the external behavior. But your SRS it should focus on the external behavior as well. Your SRS should also contain the user interface. It should also contain the constraints such as performance constraint, design constraint, recovery, etc. As well as it should also contain, suppose if there are any errors on the output. So what are the error messages? These minute things also be considered in the SRS. So we should know that the transition from the analysis to the specification is not an easy task. Why? Because the SRS is written in a natural language. There could be some discrepancies. Okay, so the transformation from the analysis to the SRS is not a straightforward task. Next, we will see about the characteristics of the SRS. There are 8 characteristics. The first one is correct. We say that the SRS is correct if every requirement included in the SRS it represents something required in the final system. That means when the final system is developed, the functionalities whichever that are present in the SRS it should be present in the product itself. It should not be like that you have specified something in the SRS and your product contains something. So the requirements should be included in the SRS. Whatever included in the requirement SRS, it should represent something in the final system. Second one is complete. We say that SRS is complete if everything the software is supposed to do and the responses of the software to all classes of input data are specified in the SRS. This means, say suppose your project is, for example, your project is addition of two numbers. So what are the different types of input data it can give? So addition of two numbers means the two numbers can be integers, two numbers can be floating points, two numbers can be one integer, one float, and like this it continues. So all type of data inputs have to be specified in the SRS. The third one is unambiguous. SRS should be unambiguous. Here ambiguous, the meaning of ambiguous is confusion. It says the SRS should be unambiguous. That means there should be no confusion in the SRS. Say suppose your SRS is of 25 pages and in one page, suppose on the page number 5, it has some terminology and in page 10, it has some other terminology. Now these two things are confusing. So it should be something like whenever you go, wherever in the inside the SRS, whatever the terminologies you use, it should be of unambiguous. It should not cause you think two ways. Okay, if a terminology comes there, that means the entire in the entire SRS the terminology meaning should be same. As because our SRS is written in formal, written in a natural language that is in English, so there could be some confusions over here. So we should maintain that there are no such confusions representing the SRS. The next one is verifiable. We say that SRS is verifiable if and only if each and every stated requirement is verifiable. That means if there exists some cost effective process that can check whether the final software meets the requirement, there should be some way to verify the SRS along with the final product. Next one is consistent. We say that SRS is consistent if there is no requirement that conflicts with each other. That means there are no inconsistencies in the SRS. Okay. Say suppose for example in page 8 of your SRS it has written like event E should occur before event F. And in page 15 it has been written as event F should occur between event E. Now, this is a discrepancy or these requirements are inconsistent. Your SRS should not contain these type of requirements. The meaning of all the sentences or whatever the sentences functionality is written in the SRS, it should be consistent. Okay. Next one is ranked for importance and stability. Now, all the requirements in the SRS, whatever have been stated, all are of not equal importance. That means some requirements are core requirements. That means they do not change with time. Once they are specified, they are done. No changes are done to those core requirements. And after that, once the core requirements are developed or coded, then a high priority requirement can be taken, then medium priority, then low priority. So like this, it continues. We say that stability of a requirement, it reflects the chances of changing in the future. Okay. Next one is modifiable. So writing an SRS is an iterative process. It is not one time process, but it is a iterative process. We say that the SRS is modifiable if its structure and style are such that if any necessary changes can be, if any changes are to be made to the SRS, it should be easier. Again, when you make some changes to the SRS, you have to make sure that it is consistent and it is complete. There should not exist inconsistency, and completeness should not be hampered. Okay. The last one is traceable. We say SRS is traceable if the origin of each of its requirement is clear and it facilitates the reference of each requirement in future development. Okay. Next we will see. Okay, so you have a quiz now. Say true or false. SRS should be ambiguous. Say this statement is true or false. Your time starts now. Okay, time's up. Next, we will see about the components of the SRS. Here, what happens is whenever specifications are specified in the SRS, the completeness is difficult to achieve. Okay, the completeness of the specifications is difficult to achieve. Now, what is even more difficult is to verify them. Now, these four things are the basic issues that an SRS must address. Now, these basic issues we also call them as components of the SRS. So, we will look into this one by one. The first one is functionality. Now, what are these functional requirements? So, the functional requirement specify the expected behavior of the system, like what are the outputs should be produced from the given inputs. So it says the expected behavior of the systems. Okay. Now, this functional requirement, it describes the relationship between the input and the output of the system. For each functional requirement, a detailed description of what all the data inputs to be given to it and its source, unit of measure, and what are the output to be taken from that function should be specified. Now, all these operations has to be performed on the input data and to obtain the output, right? Now, this includes specifying the validity checks on the input and the output. So, what are the parameters affected by the operation when this input is given to for a you say function? So what are the equations? What are the output from it? So all these things should be kept in mind. So your functional requirement, it should also state that for the abnormal situation, how your system should behave. Like for a functionality, when an invalid input is given, how it has to behave, what should be the output, or when the computation is going on, some error occurred, how your system has to behave. So all these things has to be captured in the functional requirement. The next one is performance requirements. So we all already know what is a performance requirement, right? So there could be two types of performance requirement. One is static, another one is dynamic. So the static requirements are those that do not impose a constraint on the execution characteristic of the system. For example, the number of files that are supported in a system, or the number of files that a system has to process, number of terminals, and simultaneous uses to be supported. These are all comes in static requirement, that is static performance constraint. So these static requirements or static performance requirements is also called as capacity requirements of the system. The next one is dynamic. So dynamic requirement, it specify constraints on the execution behavior of the system. Okay. Now this basically include the response time and the throughput constraints. Say for example, your SRS has it has specified like the response time should be as quick as possible. Okay, the response time, the process or the transaction has to be done as quickly as possible. So if this is a performance requirement or non-functional requirement in your SRS, how do you verify it? So it says, your SRS says transaction should be as quickly as possible, like 2 minutes, 10 minutes, how much time should be given? So there is no specific thing here, right? So instead of giving a generic statement, your SRS should say the transaction should be processed in less than 1 second, like 98% of the times. If this is a condition, if it is specific, you can verify it. Okay. Next is design constraints imposed on the implementation. Now, there could be a number of factors in the client environment that may restrict you or restrict the choices of the designer, leading to the design constraint. So what are all these design constraints? For example, your standard compliance, hardware limitations, reliability and fault tolerance, security, these are all comes in design constraints. First we will see the standard compliance. So what does this mean? The standards may include the report format, accounting procedures, and audit requirements. Basically, there could be some, the industry could be maintaining some standards. It is meeting some standard requirements. So, your design standard compliance means the report format, accounting procedures, and audit requirements should be proper. The next one is hardware limitation. The software may have to operate in some existing or predetermined hardware. It is not like whenever a new project is being developed, the client will take all the they'll purchase all the new hardware. So no, this is not done. Whatever the hardware, some existing hardware is present, they'll they'll operate the software, whatever the product given to you on the same thing. So the hardware limitations can include the type of machines to be used or the operating systems available, languages supported, primary and secondary storage, like this. Next is reliability and fault tolerance. Even this comes under the design constraint. Sorry. So the fault tolerance requirements can place a major constraint on how the system is to be designed. So this fault tolerance, they can make the system more complex and expensive. Okay. The last one is security. Again, this comes under the design constraint. Now, security requirements are becoming increasingly prominent or important these days, right? So these requirements, they place a restriction on the use of certain commands or access of the data, provide different kinds of requirements, access requirement to different people. So there are some securities should be given for the passwords or for the log activities of the system. All the users are not given the log activities of the system, right? So there should be restriction. The last one is sorry, external interface requirements. So what is this external interface requirement here? So all the interaction of the software with people, hardware, and other software must also be present in the SRS. If the product, whatever you are building, if it is communicating with the people or other software or other hardware, when those things have to be captured. First one for the user interface, right? The user manual should be created, or the user manual should have all the user commands, screen formats, like for the person who has not seen your product, it should not be a surprise that okay, so what does this screen do, it should not be a surprise for them, right? So all the things it should be given in a user manual, like explanation of how the system will appear to the user, how can he use it, all these things have to be captured. Hardware interface requirements, they specify the logical characteristics of each interface between a software and the hardware. Software here is your product, how it communicates with the hardware components. This has to be captured. Next, the software interface. That means your product, how it talks with the other software. Suppose your operating system or other software application. Even these things has to be captured in the SRS. Now we will discuss the structure of requirement document. So the requirements have to be specified using some specification language. Even though formal notations exist for specifying the specific properties of the system, most often we use natural languages for specifying the requirements. The IEEE standards recognize the fact that the different projects may require their requirements to be organized differently. That means there is no one common method that is suitable for all projects. So it provides different ways of structuring the SRS. Here you can see the introduction. The first part is introduction and the second one is overall description. Now the first two, these two sections of the SRS are same in all of the projects. From specific requirements it differs. So now we'll discuss each topic one by one. Okay. The first is the introduction section. It contains purpose, scope, overview, references, definitions, etc. So these things, what they specify, the introduction section contains these all things of the requirement document. Okay. Now, the key aspect here is to clarify the motivation and business objective that are driving this project and the scope of this project. References here, references is nothing but from where did you take all the reference for writing this SRS. If you have any definitions, abbreviations and all, you have to list in the introduction section itself. Okay. Next, we have overall description. Now, this overall description section, it gives the overall perspective of the system. That means how it fits into the larger system and an overall overview of all the requirements of this system. Again, we have to note here that the detailed functional requirements are not captured here, just the overview is captured. Here we have product perspective, product functions, user characteristics, general constraints, assumption, and dependencies. Now, this product perspective is essentially the relationship of the product to the other products, defining if the product is independent or it is part of a larger product, and what the principal interfaces of the products are. So user characteristics are nothing but the product functions are nothing but the generic functions, not the detailed one, are mentioned here. Again, if you have any assumptions or dependencies in your system, you have to list it here. Now the third one is specific requirements. Okay. Now if you are using agile methods in your project, then these two sections may be sufficient for the initial requirement phase, as these approaches prefer to do the detailed requirements when the requirement is to be implemented. So if you are using agile, you can just get started with these two sections itself. Okay. Now the detailed requirement or the specific requirement section, it describes the details of the requirements that a developer needs to know for designing and developing the system. Now this is typically the largest and the most important part of the document. For this section, different organizations have been suggested in the standard. Okay. These requirements can be organized in the form of modes of operation, user classes, feature wise, or functional hierarchy. Hierarchy wise, you can specify these functional requirements. Okay. First, in this section, specific requirements are the detailed requirements. You have the external interface requirements. Next, you have functional requirements. Then, performance requirements, design constraint, attributes, and other requirements. Again, we'll study one by one. So this external interface requirement, it has user interfaces, hardware interfaces, software interfaces, and communication interfaces. Now, this external interface requirement, what does it do? So it tells all the interfaces of the software to people, to other software, to hardware and other system. User interfaces are clearly a very important component here. They specify each human interface the system plans to have, including what are the screen formats, what is a command structure, how the menu should look like, etc. In the hardware interface, in the hardware interface, the logical characteristic of each interface between the software and the hardware has to be given. Next, in the software, in software interfaces, all the software that are needed for the particular your project to run are specified along with the interfaces. The last one is communication interfaces. This need to be specified here. What you have to specify is the software communication with other entities or in the other machines, not in the same machines but in the other machines. Next, we have the functional requirement section, wherein you can see to mode 1 to mode M again. So if we consider, if we have 10 requirements, then this is the first requirement. Okay. This is the first module and this is the 10th module. Then the first module has, say suppose 20 requirements, second module has 5 requirements. Likewise, all the functional design details, functional requirements are given here, and these are detailed functional requirements so that it is easier for the developer to design and develop the system. Now, for each functional requirement, the required input, what will be the output, and how the processing of the input has to be done. These all things are specified. Again, for the input, what should be the format of it, the source of the inputs, any units of measure, valid ranges, accuracies, these all things have to be specified. Okay. Now, apart from that, we have performance requirements. Now this section, what it specifies is it says both the static and dynamic performance requirements are captured here. If you have any performance constraint also, it is captured here. Next, we have the design constraint. So here design constraints specify all the constraints that are imposed on the design, like security constraint, fault tolerance, standard compliance, all these things are mentioned here. In the attribute section, this specifies some of the overall attributes of the system that should have. Any requirement that is not covered in any of this section will be covered in the other requirement section. Getting it? We will have a quiz now. The question here is, in SRS structure, which section specifies all the constraints that are imposed on design? You have 2 minutes of time. Your time starts now. Okay, time up. That's it for today. We'll conclude our session. Thank you.